Let's talk about falling things. You might think that the heavier something is, the faster it falls, right? So if I have something that weighs 1 pound and something that weighs 2 pounds, the thing that weighs 2 pounds would fall twice as fast. You might have seen videos that contradict that and say that all objects accelerate downward at the same rate. That if I have two things, one really heavy, one not so heavy, and I drop them from the same height at the same time, they'll fall at the same rate. That's a concept that involves what we call free fall. There are tons of videos showing this. But is that the whole picture? We're going to look at that in real life on this episode of Science Deconstructed. So let's answer the question, does something heavier fall faster than something that's lighter, that doesn't weigh as much? In demonstrations that are often shown online or in classrooms, it's often tied to a concept called free fall. Free fall occurs whenever the only force acting on an object is the force of gravity. The force of gravity acting on an object, we call that its weight. So whenever the only thing that's pulling something down is its weight and no other force acts on it, we say it's in free fall. And yes, in free fall, all objects fall downward at the same rate. And you can approximate free fall conditions over very short distances, which is often how this is shown. Somebody dropping something heavy and something light from the same height at the same time over somebody's height will hit the ground at the same time. Air doesn't really come into effect over such a short distance as the height of a person. But what about in longer falls? How much does air impact the falling object? My team and I decided to try an experiment, and we took two objects. One of them has a mass of 1 kilogram, one of them has a mass of 2 kilograms. So one weighs twice as much as the other. We brought them to the roof of this building and dropped them at the same time. Let's take a look at the results from that fall. As we can see, the heavier object hit the ground first. But how can this be if all objects are supposed to hit the ground at the same time when dropped from the same height, right? Well, air comes into play. And air resistance depends on how fast an object falls, right? So eventually, as it falls faster and faster, the air resistance is going to build up more and more, get stronger and stronger, and will eventually balance the force of gravity. So for an object that's, say, 1 kilogram, it weighs 10 newtons. That's how we measure weight in science, newtons, named after Sir Isaac. And so eventually it will have a force of air resistance pushing upward on it of 10 newtons. For an object that, say, weighs 20 newtons, mass of 2 kilograms, it's going to have an air resistance of 20 newtons to eventually balance that out. In other words, it's going to have to fall faster because air resistance depends on how fast something falls. What's the takeaway? In free fall, when there's no air, when the only thing acting on an object is the force of gravity, yes, everything falls downward at the same rate. It's going to hit the ground at the same time, even if it's a hammer and a feather. But in reality, when we take into account air, even over a relatively short distance like the height of a building, the heavier object will indeed fall faster. But is it going to fall twice as fast because it weighs twice as much? No. It will fall a little bit faster, but not twice as much. And that is falling deconstructed.